Okay, so welcome to the Research Assistance Services, and today we are going to learn how to extract data from PISA and then use it for our research. Actually, um, PISA simply means Program for International Student Assessment, and like every 3 years, they conduct a series of assessments to um, assess student proficiency in mathematics, reading, and also science. Okay, and on top of that, they also ask students a couple of questions on um, to measure their level of, let's say, for example, anxiety, motivation, bullying. So it's just like motivational questions to see how all those things um, actually also affect their academic performances. Okay, so when you want to use data for PISA, this is where you come to. And if you are not aware of it, you can just go to PISA, and then actually Pisa is also a city in Italy, so you should type Pisa. Let's add data to it, and we are going to look for this one. So you can see we have the first cycle. Actually, what they have here, the data set they have here starts from 2000. So you can see every 3 years they update with new data set. Okay, so we are waiting for the 2021 PISA results to also be updated as well. Okay, so in this tutorial, we are going to see how to use data from PISA 2015. So I'm just going to click on it. Well, by the way, this is the database, and these are some documentations that you can use. So if you want to read more about the assessment and analytical framework for any specific year, you can just click on this, the 2015, and you read it. Okay, if you want technical standards, if you want survey implementation tools, technical reports, you can read all these things. Okay, yes, but I'm just going to go ahead and click on the 2015, and you can see the PISA 2015 database is open. So you can see we have download information and instruction. You can make some time to read all this information because they are extremely important. Okay, and then we also have questionnaires or the survey that were administered to students. So we have student questionnaire, this computer-based assessment, this paper-based assessment. We also have student school questionnaire, computer-based assessment, and we also have paper-based assessment. Okay, and they also ask questions. They also ask student questions on education, career aspects. Okay, they also have ICT familiarity questionnaire for students, parent questionnaire, teacher questionnaire, national questionnaire. Okay, so you have like thousands of data sets that you can use for your research at any time or in any time at all. Okay, so the data set for this questionnaire has been structured either using the SAS format or the SPSS format. Okay, so if you are a SAS person, you can use download the data set here. If you're an SPSS person, you can also download the data set here. Okay, now we are going to download the data set from the SPSS section. Okay, that's what we are going to use, but we are not going to use SPSS to analyze this data. I'll download it here, but we are going to analyze it in R. I'll do my best to do a different video that you can use SPSS for the analysis, only SPSS. Okay, but for now, we are going to do it in R. So I'm going to focus on the student questionnaire data file. So please click on this. When you click on that, it should download. Okay, but because I have already downloaded it, I'm not going to download it once again. Okay, so I will delete that. Yes, so click and download it. The size is 419 megabytes. Okay, and after downloading it, make sure to extract the file as well. Okay, so these are some other data that you can maybe download and then use it for your research, but we are going to use the student questionnaire data file. Okay, then it will interest you to come and then click on the student questionnaire computer-based assessment and then see the structure of the data set. For the student questionnaire for PISA 2015 computer-based assessment, okay, so you can read the preamble to get more information about this survey. Okay, but you can see, for example, it says in this questionnaire, you will find questions about the following topics. It's about you, your family, and your home, how you think about yourself, your school, your education, your school schedule and learning time, school science, learning in school, and your view on science. Okay, so you can see it's also put so many information here, so it is not mandatory. Okay, yeah, so for example, it says the first question says like, what grade are you in? Okay, so it has a lot of questions for student to answer, a lot. And you can see like this one, thinking about the about this academic year, to what extent do you agree or disagree with the following statement? My parents are interested in my school activities. So you can see they have four Likert scale rating. There is nothing like neutral over here, so it is either you agree or disagree, which really makes sense to me. Okay, otherwise students would like to choose the middle section, neutral throughout, and it may affect the quality of the assessment report. Okay, so this is the questionnaire on student assessment and computer-based assessment. Okay, now you see the way this questionnaire is structured, it is really difficult to know what, for example, ST082 represent. Is it talking about student motivation? Is it talking about anxiety? Is it talking about bullying? It's really difficult to actually say that. Okay, so there is another technical report that you need to look at to extract all this information. Okay, from so this technical report, I check online. So when you Google, for example, scaling property procedures and construct validation of contest questionnaire data, you are going to get all the information about the student contest questionnaire, for example. Okay, because when you look at this, it gives you first introduction, scaling methodology, and construct validation. This is extremely important if you're writing your method section. Okay, and you can see school questionnaire, derived variables, educational career questionnaire, ICT familiarity questionnaire, parent questionnaire, teacher questionnaire. Okay, so and it also have the PISA index of economic, social, and cultural status. Okay, so it has all information on all these things. Now, what we are interested in has to do with the kind of derived variables that are in this data, in this questionnaire that we have just downloaded. Okay, so I'm quickly going to go ahead and then just type something like ST119 in this report. For example, ST119 to see the kind of information that I'm going to get. Okay, so ST119 actually talks about student motivation. Okay, so let's start from the beginning and see if we are going to get more information. So when you check here, it says, yes, achieving motivation. That's the description of this variable. So if you look at the topic here, it says student questionnaire derived variables. So for each of these questions here, you can see ST119, it asks questions on to what extent do you agree or disagree with the following statement about yourself. Okay, so I want top grades in most or all of my courses. So when you check here, ST119 is talking about motivation. Okay, so if you are looking for motivational variables to analyze, you can focus on ST119. Okay, and for this tutorial we will consider motivation, achieving motivation variable. And then let's take a look at this one, ST118, which also talks about anxiety. Okay, test anxiety. So ST118, I think it should be here. Good. So it asks the same questions. To what extent do you agree or disagree with the following statements about yourself? So the first one has to do with, I often worry that it will be difficult for me taking a test. So this measures test anxiety. Okay, so there are 1, 2, 3, 4, 5. There are 5 questions on this, and there are 1, 2, 3, 4, 5. Also, there are 5 questions on this. Okay, so we are going to pick test anxiety, achieving motivation, and let's scroll a little bit upwards and see if there are other variables that we can leverage on. Okay, so I'm also going to consider sense of belonging. Okay, this one variable that is highly looked up to in the literature. And also no, I won't consider being bullied in this case. Okay, so I won't consider a lot of variable. I'll just consider sense of school belonging, and also test anxiety, achieving motivation. And we can also look at some demographic variables like how do you call it? Let's check. Okay, so which one should we pick? Okay, I know what to do. Okay, so yeah, let's pick these variables. First, let's look at the sort of questions they ask on sense of belonging. So we can look at ST034. So I'm going to search for ST034. Okay, so it says, I feel like an outsider at school. I make friends easily at school. I feel like I belong at school. Okay, so these are the sense of belonging questions. Okay, so what we are going to do is that today we are going to learn how to extract this data set from in R, and in subsequent video we are going to learn how to use these data sets to perform SEM, structural equation modeling analysis. Okay, and we will find out how these variables actually have an effect on student academic performances. We will look at either reading achievement or mathematics achievement or science achievement. Okay, so by now I'm sure you are done downloading your data, so we can proceed quickly and see how to work it out. Okay, so after you have downloaded your data set, it's going to be in a zip file, so you need to download it. You need to extract the zip, sorry, there's the content. Well, it has like QQ like this. For this is a like a limited version, and this is the comprehensive one. You can click on this to read more about some few information on I think bullying victimization, okay, or student exposure to bullying. There are some few concerns that they raised over here. Okay, so you can take a look at it. Okay, so the next one, this is the data set that we are going to use. So when you extract, you can see this data set, the size is 1.48, about 1.5 gig. So you can see it's a lot. And this is it 5 megabytes? I suppose. Okay, but we are going to use this data set, and I'm going to copy this and put it in the folder here. I don't want my folder to be messed up, so I'm going to go ahead and delete this one because I don't need it anymore. Oh, I've already opened the file. That is well. Let me just close it. Okay, so in my folder, I'm going to have only the R script that we are going to work on, and also my data file. So I'll open this in SPSS. It should open quickly. You remember that the file size is a little bit big, so depending on your computer capacity, it may take a while, but generally SPSS does take some time to load. Okay, so this is a data set that we have, and these data sets consist of thousands of variables, countries. Okay, it's thousands of entries. I mean, thousands of entries. So we have data on like country ID. So the first country, for example, is Albania. So their country ID is 8. And they also have data on the country school ID. Okay, so you can see in Albania, the first school, the ID is 800001, and the second school 80002. Okay, so you can see the beginning is like 8, the country is here. So the beginning of the country school ID starts with the country code, and then it continues. Okay, so you can see there are so many information here, so you can also access that and use it. We also have country student ID. So each of the students have their respective IDs. Okay, and we have CYC. I don't know what this means. We have, I don't know what this means. We also have region. We have stratum. And so many other countries information. Okay, so let's go to the variable view and preview some few things. Okay, so in the variable view section, if you scroll down, you can see we have about 921 variables, and these all account to the reason why the data set is so big. So we are going to just extract a few information from this data set. Okay, so first okay, so if you want information on the specific countries, like country ID, you can just click on this and it's going to give you information about all the countries that participated in the PISA result. Okay, so in our study, or in this example, we are going to focus on the United States data set, and we are going to see how the variables we will select work for this sample. Okay, so just have in mind we are going to use the United States sample, and if you check here, we mentioned that we are going to focus on just a few variables. We are going to look at the bullying, and then text anxiety, and then achieving motivation. Okay, so let's go to our R, and oh, this is wrong. And first, please load the following packages. We will need them. If you don't already have it, you can use this line of code to download it. Okay, yeah, so you can run this line of code to download or install the foreign package. Okay, I already have it, but no problem. I can still install it. So you can do this, and if you also don't have the site package installed, you can do install the packages, and then you can put the site, okay, and then you install it. But I already have it. So the next thing that you need to do actually is not to load your data set, but rather to set your working directory. Okay, so we need to set working directory now. Okay, so to set your working directory means that you are telling RStudio that look in this direction, you'll find my data set. So you go to session, set working directory, choose. So this is my working directory. I click open, and you can see the working directory has been set for me. Now, if I type get working directory, I know this is where I'm actually going to work. Okay, good. So now that I know my working directory, the next thing that I'm going to do is to load this data set, and I'm just going to copy the name. You can rename it if you want, and I type it there. So you remember to load these two packages, okay, and I'm just going to name these data read.spss, and then when you run this could take some moments to load, so you may have to be patient a little bit. So let's see what happens. Okay, so our data is downloading, and when you come to your environment section, you can just click on the variable to just preview it, so you can see we have other countries and everything there is here. So if you check over here, you can see COLS, and when I click here, it takes me all the way to the last end. Okay, so you can play with it to have a feel of how the variables are structured in RStudio. Okay, yeah. So the next point, we are going to extract data for the variables that we are interested in. I'm going to list the variables here. Okay, so so we type this. If you are new to R, this is what we use as assignments in or equal to in R, but you can still use this. Okay, but I prefer to use this, right? So this is less than, and then the minus sign, and there you go. Okay, now I'm going to extract these variables in that we want to work with. So the first one, let's come here. Let's look at the, let's start with ST034. ST034. Okay, so I'm going to open up the questionnaire here, the student questionnaire, ST04. Okay, good. And if you look at this, you can see we have ST04 question 01 TA, ST04 question 01 02 TA. Okay, if you check the SPSS data file here, let's just copy this. Okay, and let's come here and search for it. Yes, so you can see the question is, I feel like an outsider at school. Okay, and the response, oh, where is it? Okay, so when we look at this, you can see strongly agree, agree, disagree, strongly disagree. And wherever you see 5, it means the person skip it. 6, not reach. 7, not applicable. 8, invalid. 9, no response. Okay, so this is the data that we are going to extract. Okay, so let me partition my screen very well, and then partition R as well. Okay, so I'm partitioning everything, and I'm going to copy this. Okay, it's a lazy way of doing things, but don't want to complicate things here. So okay, so which means that we can just copy paste because and then just change the name. Okay, that will be much more efficient. So remember we have 5 questions to no 6 questions. Okay, so okay, so here we are going to replace this by 2, this by 3, this by 4, 5, and it's left with the last one, and this by 6. Okay, just make sure that everything is in order. Okay, so this variable, remember it is belong. Okay, sense of belonging. Okay, so you can see there's a question mark here before I hit the enter or the written button. So the next one, we are going to go back and look for ST119. Okay, so for ST119, we also have 5 questions. Yes, so we are going to copy these 5 questions. Okay, so do this. So we're going to do for all of them. Okay, so you can just go ahead. I'm going to pause the video and do all these things real quick. Okay, no problem. Let's just continue. Okay, so we have 3, and then we have 4, and then 5. Okay, actually, analyzing data takes time, so you have to be a little bit patient with yourself. Okay, so this is belong, and ST119 represents, let's take a look, ST119, achievement variable, achieving motivation. So I'm going to copy this. Okay, so that's motivation variable. And our next one, ST118, which is on top of this. That is also measured by 8 questions. Okay, so look at this. Okay, and I'm just going to copy paste and then change the name. Okay, so this is 2. Some mistake here. Sorry. 2, 3, 4, 5. Okay, so this I change this to 3, I change this to 4, and then I change this to 5. Okay, so at this point we are done extracting all the data that we want for the variables that we want for our study. Okay, and the next thing that I want us to look at, because we are interested in the effect of this variable on student academic achievement, I want to show you the achievement variables that are represented in the PISA dataset. PISA actually uses something called plausible values, and instead of reporting students' responses directly, they use item response theory to rescale all the responses to what we call the plausible values. So the plausible values represent the students' achievement scores. Okay, so anytime you see a research paper that says that this has an effect on students' reading achievement, if they are using PISA data sets, they're talking about plausible values. Okay, so we have plausible values for student like mathematics achievement, we have for reading achievement, we have for science achievement, we also have for competency subskills. I've not used this before of science. Okay, so their achievement, they are actually many. Okay, so we are going to focus on just mathematics achievement. So, and we are going to use all the 10 plausible values. So I'm going to extract all these 10 values, and the first one has to do with, remember that these plausible values is not in the student, is not written in the student questionnaire. That is why I am not searching for it here. Okay, so we will use this, and the first plausible value is called PV1 math. So okay, let me name this text anxiety. Let's see how they label it here. Let's check here, ANST. So just copy this, and don't forget, when we put the pound sign or the hashtag, would mean we want to put a comment that R wouldn't consider as a code in analysis. So from here onwards, we are going to type the plausible values. So this is PV1 math. Okay, and so remember I said we are going to use all the 10 plausible values, but if you want to use maybe just a few of them, you're welcome to do so. But to enhance measurement accuracy, I usually try to use all the 10 plausible values. Okay, so this is 5, this is 6, 7, 8, okay, 9 and 10. Okay, so this is 9, this is 10, and this is 9. Okay, so these are the variables we have, and we should ask ourselves one more question. Do we actually want any variable on demographic characteristics of the student? Of course we do. So we need to go search for it. There is some variables that I would like to use, something like let's take a second to take a quick look at this. Okay, let's go up a bit. Okay, I can see something like, okay, first let's take a look at something like gender. Okay, student gender. Okay, so for gender we have male, female. So okay, so this is the code for gender. Okay, so I want to extract gender too, so let's put it here. I want to put gender at the first section. Okay, so this is gender, and then I'm going to use gender. Okay, and then the next one we have let's take for example okay, let's just consider gender. In subsequent research, I'm sure you can consider other variables. Okay, select as many variables that you want. Okay, so you can click the run here to run the code, and after selecting the variables, we want to extract this set of variables from the big data set that we have here. Okay, so let's just load the data set and call it data.us only. Okay, and so data into brackets, data, then we can subset the country ID equal to the US code is 840, so we type 840. Okay, and then we can, this help us to only subset the US sample. So you can see we have 8,000, we should have 5714. Okay, good. So if you look at this, it says USA 840, USA throughout. Okay, so next, we are interested in only these variables. So instead of extracting just this, we can also add VAR, which represent the variables we have here. And when we run this line of code, you can see we have 27 variables selected, and we have 5,712 observations. So when we click here, and we extend this, adjust this a little bit, we can see all the variables. So these are the plausible values. Okay, but you know, it is very difficult to actually have the name of this in mind. So let's try our best to rename all the columns. Okay, we can assign new names to the column, and for gender, it's going to remain gender. Okay, and for the belong, we can use like yeah, we can still use the belong. Okay, belong one, so it represents the first question on belong, and the next one will be belong to. Okay, this way it makes your data readable. Okay, so this represents belong 3, 4. This represents 5, and this also represents 6. Okay, so this one is MO. Okay, so motivation. Okay, so let's just use motivate 1. Let's just be consistent. Okay, this is 2, and then the next one is 3, the next one is 4, the next one is 5. Yes, so in the final one we have to do the anxiety, ANXTEST. Okay, so we do a similar thing for this. Okay, so this is 2, this is 3, this is 4, and this is 5. Okay, as for the plausible values, I'm not going to tamper with them because you can easily discern from the values. Okay, so now we want to rename each of these columns. We want to change this name to this name. So what we do is that we are going to type column names, and then we can type data.us only, and over here we can look at renaming all these to where. Okay, let's name this as rename. Okay, and let's run this. Okay, so we are basically changing all the column names here to what we just defined. Okay, oh, it couldn't find rename. Okay, I ran it once again. Oh. Okay, so let me change the name and see. Column names. I know here has to be data.us only, and here has to be column names. Okay, good. I think probably the rename we use is an inbuilt function. That is why it wasn't working. So when we preview the data, you can see we have been able to change all the labels into something very meaningful. Okay, and our next point, you can see, first let's do some summary statistics about the data. So we have summary data.us only. Okay, so this summary statistics is very important because it gives you the minimum, the mean, the median, and also the maximum. For gender, the minimum should be 1, maximum should be 2. Okay, and if you look at the belong variables, you can see the number of missing response. So wherever you see NAs, they mean missing response. Okay, so some of the variables have missing responses, others do not have. Okay, so what we are going to do now is to, because our data set is big enough, is to exclude other people that have missing responses. Okay, so I'm still going to use the name data.us.only, and I'm going to use the subset function, and then we put data.us with this, and then we are going to focus on complete.cases. This complete.cases, it helps you to only select the rows or respondents that have responded to all the items that we selected. That's why it's called complete.cases. And we use data.us only. Okay, so when we run this, you can see the sample size has reduced from 5,700 and something to 5,193. Okay, so okay, save it, and you can see, let's run this again, the summary statistics, and you can see there is no NAs in our data set here. Okay, so now we've been able to extract our data, and one other important thing is that you wouldn't like to be going through the process of loading the data set. That is going to take so long. So I'm going to save this data file as a CSV file, so that in future when I want to use it, I just use the CSV file that has been cleaned, and it will make my computation much faster. Okay, so if you want to save your file as a CSV file, you can use the write.csv into bracket data.us.only, and you input the file format. The file over here means the name that you want to use for your study. Okay, for this data set, I'm going to type PISA research data. Okay, don't forget to add the extension .csv, and row dot names equal to false, because I don't want it to assign unique ID to the rows. I don't want it. Okay, so now the data set has been saved. Let's go to our folder and then check. So when you look at this place, you can see this data was just saved here, and when I open it, you can see we have gender belong 1, belong 2. When we scroll down all the way to the bottom, you can see this is the last participant. Okay, so this is how to extract data from PISA for your research. Okay, so in the subsequent video, we are going to learn how to use this data to check, for example, the reliability, the validity, how to do EFA, exploratory factor analysis, how to do structural equation modeling, and so many other things just from this data set. Okay, so this is all I have for you at the moment, and I hope this really was helpful to you, and I appreciate that you took some time to watch this video. Thank you.